Hey everybody, I'm Taylor. I'm here to talk about Crewbit development and Google. Specifically, I work on Rust and C++ interop, and I'm also a former member of the Lang team and the compiler team. Rust has taken a hold at Google. From smartphones, watches, and web browsers to version control systems, server-side parsers, trusted execution environments, and even security keys, Rust is making Google's code more safe, secure, and reliable. However, in a code base with billions of lines of code, you can't just flip a switch and then have everything be in Rust. Instead, we're taking advantage of Rust's security and reliability gains by choosing Rust for new software and by using high-quality Rust libraries to replace vulnerable low-level libraries. Today, Rust adoption is providing wins across our products. We've rewritten parts of Android's core, including portions of its C standard library in Rust. Rust is also embedded in the dynamic loader and disk crypto, so Android devices actually can't even boot without Rust. Rust is even in kernel drivers now. In total, we've shipped over a dozen components, including drivers for Bluetooth, Wi-Fi, and USB, as well as security features like our attestation system. This is a big step towards improving the reliability and security of one of the world's most popular operating systems. We've also replaced Chrome's C-based font rendering stack with a new one written in Rust. The old rendering library, FreeType, has been the source of 109 CVEs and one actively exploited zero-day vulnerability. Since switching to Rust, we've greatly reduced our security maintenance burden. We've also replaced libavif with a Rust-based drop-in replacement called CrabbyAVIF, and we're looking to adopt Rust for other codecs as well, including FLAC audio decoding. We're also making it easier for developers to write safe applications on Google Cloud with the release of the Cloud Client libraries for Rust, providing a supported idiomatic way to use Rust across more than 140 Google Cloud APIs. Rust is also a first-class language for Fuchsia, Google's open source operating system. In fact, as of this August, there are now more lines of Rust code in Fuchsia than there are lines of C++. Key components like Starnix, Fuchsia's Linux syscall translation layer, their next generation file system, FXFS, and parts of the Bluetooth stack are all written in Rust. Our server-side memory safety team is also providing alternatives for parsing by exposing a C++ interface onto popular existing Rust libraries. Today, we're shipping proven memory-safe alternatives for JSON parsing, XML parsing, audio decoding, and stemming. As an added bonus, switching to Rust provided a measurable speed boost for many of these libraries. Parsers are highly security-sensitive software, so Rust provides critical benefits here. We're using Crewbit, our Rust C++ interop tool, in order to make these transitions possible. But there are still systems and use cases where it's hard to adopt Rust. Adopting Rust-based parsers is relatively straightforward because parsers tend to be leaf dependencies, meaning that they don't depend on a lot of the rest of Google's existing code and infrastructure. Similarly, Android and Fuchsia's Rust adoption has been successful in part due to strong cross-language ABI and IPC boundaries. But in order for Rust to integrate further into our code bases, it needs to be able to interact with our C++ code in a native way. That's why we're investing so heavily in fine-grained Rust and C++ interop. To hear more about our interop efforts, please join Tyler and I for our talk on Thursday. We'll share how we're enabling Rust to thrive alongside billions of existing lines of C++ at Google. Thanks, everyone.